at 1:09. So I don't know.
She does not want to join.
Okay.
You can text her to say join. Maybe she's asleep.
I thought she texted because she did not find anyone here. So I wonder why she's not here.
So today we are working on number.
I think we did the question 2 of that assignment, of the first assignment. No, of the, what is it? Of the physics or of the waves. I don't know.
We are done with question number 2.
No, we did not do question 2 of this one. Of
Yes, that's what we want.
2606. Yeah, we want
This
to do
is
2606, question 2.
which is this one, isn't it?
Yeah.
So we are given that series which says a curve between I and omega in series LCR circuit connected to an EMF E naught. So that is the EMF that we are given here. E naught sine omega t. There's a peak. I is equals to I naught and omega is equals to omega naught, which is the resonance. Suppose omega 1 and omega 2 are two values of omega on both sides of omega naught. At the value I is equals to I naught over root of 2, show that omega 1 and omega 2 are half power points, and omega, change in omega is equals to omega 2 minus omega 1, which is equals to R over L. So those are the two things which we are supposed to show for A. The quality factor of the circuit Q is W naught L over R. So this question is a matter of just more of derivations so that we arrive into showing. So what is it that we are supposed to show? The first thing that we are supposed to show is W1 and W2 are half power points. So this is the first part which we are going to show. They are half power points. When you are done, show that this delta W is equals to this. So in other words, you want to know when you are done, when we are showing that delta W is equals to R over L, then we'll be done. And also when we show that they have power points, there is a way of showing how W1 and W2, which means omega 1, omega 2, are half power points. So it's a matter of just derivations. So let's start. You see here, there's not a joint.
No.
I am here.
Oh, yes, is here.
Okay.
Yeah, I just joined now.
All right. So
listening.
let's start. So I was just telling you that what we are supposed to solve here in our question, we are supposed to show that the omega 1, omega 2 are half power points. So this is the first thing that we have to show for A. And we must also show that that delta omega or change in omega is equals to R over L. So when we reach that point, then we'll be done. So there are some basics which you must master according to the symbols. What we are solving for, show that W1 and W2 are half power points, and this change in omega is equals to that, and that the quality factor Q is W naught multiplied by L over R, which is the resistance. So the current in series LCR circuit I naught is equals to I, the current is equals to initial current, which is at resonance, and omega is equals to W naught. So this information we were given on the question paper already. We are not deriving it. Can you see here? I naught is equals to I, and omega is equals to omega naught. So this information was given. Are we together?
Yes.
The resonance was given, which is W is equals to W naught. You were given this one. So we did not formulate these equations. So these equations we are given already. That's why it's saying it's given in the problem. And we are told that at omega 1 and omega 2, I, the current, remember at metric where we were used to say the root mean square, the RMS current, RMS voltage. Do you still remember that one? For physical science, do you still remember root mean square? Or you have forgotten?
I've
Eh?
forgotten.
But you know it's in metric. The VRMS, the power RMS, the root mean square, whereby it says P max. All right, in our next meeting, I will show you the formula.
Okay.
Where on the formula sheet for physics for grade 12. So that's where it's coming from. These are the basics. So you must know this root of 2 is coming from the root mean square, which means you are going to multiply by the square root of 2. So this is your prior knowledge. I think maybe when we're doing that one, at metric, people, they neglect this one. P max then is root of 2 RMS. So you should be knowing these things as the basics. Isn't it? We are relating with what we did at metric so that we can at least understand some of the concepts, isn't it? Hello?
Yes.
Hello.
Sorry,
We
I
still
was
hear
on
you.
another call. Someone just called, so I told the person that I'm in a meeting now. All right, apologies for that. Yes. So this is the basics for grade 12 physics. I with the root mean square, P max, root P RMS. So we are going to work on it, then I will show you. So this information was the one which was given. Then for the inductor, capacitor, resistor circuit, that's what they are just representing, LCR circuit. So Z will be the impedance. So you must just know these formulas, because you know when you go to physics, you are not given these formulas. So you must write them down so that you can have your formula sheet which you can formulate, because all these assignments, you are creating formulas. That's the logic of them giving you assignments, so that when you go to exam, you'll be knowing the formulas that you need. So these are some of the formulas that you need. The formula for inductive reactance, but we have not yet answered our question. It's just helpful information that you need as notes. The capacitive reactance, XC, how are you going to calculate it? Calculate the current in the circuit, and then Z is the impedance, which is given by the formula of R squared XL minus XC, where XC is the capacitor, L is for the inductor. So our circuit, while they call it LCR, it is an inductor, it is a capacitor, and a resistance. So at metric level, we are only having a circuit which is having what? A resistor only, isn't it? The components for a metric level, we are just having resistors, voltmeter, and ammeter. But now, look, our components, we are now having a capacitor and the inductance, which is another component which they've added in the circuit. So we must be familiar with these things, not to be scared of what is happening. You don't even see what is happening in the circuit. All right. So familiarize yourself with the formulas. The resonance W naught, which is 1 over square root of the inductance and the capacitance. So these are just formulas which are helpful when you are making your own formula sheet. All right. Power is given by P. This one is from metric. I squared R. Then the one which you want to solve today is this one. If our power is equals to half of the P max, then these are the half power points or K. So this is what is going to be helpful for us today in answering the question. When we know that our power is equals to half of the P max, which is the maximum power, that's when we use the root mean square from metric level whenever they see P max. So this is when we determine whether it's a half power point. So it's a half power point, this P, if it's half of the maximum power. So this P will be a half power point. So this is the one that we are looking for. Once we find that the P is equals to half, that P is equals to half of the P max, then we conclude that that P is a half power point. Any question there? Power P. So when you find that P is equals to half of the P max, then that P is called a half power point. So from the definition, I'm asking, is there a question?
No.
It's clean. All right. So the P was not given, so which means you must know the formulas. All right. So the half power points, these are just formulas I will share with you. This is the one which I was talking about from metric level, where I max, these are the points current, where it's I max over root of 2. The root mean square. IRMS. And then, yeah, this one is not relevant to what we are doing. What is relevant is this formula, which I was referring you to, the half power point. When P, now they just made it with one denominator, so P is half of P max. So if that P is half of the P max, then this P is the half power point. That's what they just refer to there. But this we come back to metric AC, alternating current, direct current. It's coming back now when we are dealing with AC and DC circuit. So power is I squared RMS multiplied by the resistance. This is a very important formula which you must jot down. So this P which you are talking about is equals to the current, but this current is a root mean square current, RMS current, multiplied by the resistance. What do we mean by RMS current? This is what we're referring to. I max over root of 2 is the RMS current. So you write here, it's your I R M S. That is how you know it's the root mean square. So this is what they are referring to here. I RMS multiplied by the resistance. So those are the two formulas that we are going to be using. The other ones, they are just for general, for just knowledge, which you must just know when you are preparing for your exam. But for now, answering our question A, we need those two formulas. All right. So we are going to find the frequencies. So first, we must show that the power W1 and W2 are half power points, which means are half the maximum power. That's what we want to calculate. So that is the step number 2. And then this one, we are going to show what is this equals to, which is R over L. And you show that is equals to R over L. So bear in mind about those ones. That is what we are going to be working on. All right, so let's start with the one which we are showing about half power points. All right, so maximum power is given by that, which is P max is equals to half. It's I naught squared multiplied by the resistance. So we are answering for that question for half power, which is the first one for A. That is the one which we are answering here. So which means power at W1 and power at W2, it's P. So P is given by this, I naught over root of 2. Where did we get this I naught from? Where did we get this one? Which we substituted there. We got it from our question here, which was given from the point where it says given. Can you see our I? I is what?
Mm,
Can you see that
over
I naught
Yes.
over root of?
2.
Yeah, that is our I naught over root of 2. That's what we are going to be using there. So first we are going to start by calculating the power, half power points. Then the next step we calculate the other ones which we have to deal with. So let's calculate the half power points. For the half power points, it's easy. You are just supposed to have your formula, which is this one, which you must just know, the formula for maximum power. So the formula of maximum power, you write it down. Maximum power is equals to P max is equals to I naught squared multiplied by R. So the P max is equals to I naught squared multiplied by the R, which is the resistance. So as we want the P, remember when we said if we are having a half power point, P is equals to half of P max. When we reach a point of P is half of P max, then we know that this P is a half power point. That's where we want to go. So first you write that formula. Where there is I naught, you are replacing with what? Where there is I, you are replacing with I naught over root of 2. So is that step clear where I naught over root of 2 is coming from? Or you are lost? So that we can do it step by step. Isn't it on our question here? We are given that our I naught is root of what? It's root of 2, this one. Our I, which we are going to use there, it's I naught over root of 2. So I'm going to use I naught over root of 2. Then I replace it here where I put my P max. That's what I'm just doing there. So you use P max is equals to I naught over root of 2. And why is it P and not P max? Why is it P and not P max? The P there, why is it a P and not a P max? The P, the power. P, the power is equals to I naught over root of 2 bracket squared multiplied by R. What happened? If you are quiet, then it won't work.
No, we're still adjusting.
Ah.
We're still adjusting. Like, yeah, I think, yeah, this one is very new. So, hey, but it's fun. We're not keeping quiet because we're ignoring. We're just digesting in, yeah.
All right. So when we square P, what happened to the half power point P? You are having P max, and then this is we are having half P. So we are having this P which is here, this P which we are referring to as I naught over root of 2. Then you square everything. You square everything multiplied by R is equals to P max. Remember, we said P is equals to this P, which is given by that formula, which is I naught squared multiplied by R. So that P is equals to what? So when you simplify the P, here we are simply simplifying the P before we equate it to P max. So if our P give us half of P max, that's when we conclude that it's a half power point. So let's solve the left-hand side first. I naught squared over, so which means we are going to get I naught, which is squared, multiplied by R. R is not being squared. Root of 2 squared under the bracket is going to become what? 2 is equals to what? Then we come back to our definition. We say, but from the definition, you told us that P max is I naught what? R. So which means where there is I naught R, I naught squared R, which is this one. Whenever you see I naught squared R, that's when you put what? P max. So it's coming from the half power point, P. So from your definition of that half power point, we know that the half power point P is I naught squared, I naught over root of 2 squared multiplied by R. Then continue solving that P. Then you equate it to P max. So when I solve the left-hand side, I'm going to find out that no, this I naught R is the same as P max. That I naught R is the same as P max. And then there's a 2 down there. So it's divided by what? By 2. And on my right-hand side, you can still see that on the right-hand side, they still also have P max. So we conclude that P is equals to P max over 2. Therefore, W1 and W2 are half power what? Points.
Sorry, before you proceed, Ne?
Yes.
I think I'm going. You're saying P max is equals to I naught squared times R, ne? So where is the square root of 2 coming from?
All right.
Yeah.
Let's clarify that. So let's start again. All right. So we said for us to have half power points, we have a condition that must be met, isn't it? For it to be a half power point, for points omega 1, omega 2, for them to be half power points, which means P should be equals to half of P max.
Oh, okay.
This is the condition. For these points to be half power points, P must be equals to half of P what?
P max.
So the power at W1 and the power at W2 it's P, which is the P which we are having, this P, is equals to I naught over root of 2 squared multiplied by R. That is the power at W1 and W2. Where did you get that power there at W1 and W2? Where did you get this power which you are saying? Because this statement which we are saying P max, if the power at W1 and W2 is equals to half of P max. So where did we get this power at W1 and W2?
Didn't we get it from the question?
That's what I was saying. Because we were given from the question that your I naught for W1 and W2, this one, the I naught at W1 and W2 from the question. What is I equals to?
I equals to I naught over square root of 2.
So the current which we are going to use at those points, W1, W2, which means it's going to be I is equals to I naught over root of 2 for P. So where I'm going to write my P, I'm going to say my P is going to be, instead of saying I naught squared multiplied by R, instead of saying I naught squared multiplied by R, this is the formula for P max. For me, I'm going to say I naught over root of what? Over root of 2. And where am I getting it from? From the given information on the question. It's I naught over root of 2. Then I square it. And then I multiply by what? The R. That is the formula. So when I solve this one, and remember I must also square. I forgot to square. There must be a squared here. There must be a square. And at the same time, I must know the formula for P max. So my P max is equals to, what is P max equals to? It's just I naught squared multiplied by what? By R.
Resistance.
Is that correct?
Mm-hmm.
So if you want to show that W1 and W2 are half power points, they must meet a certain condition, and the condition that must be met is that P must be equals to half of P what? P max. Are we together?
Mm-hmm.
So how do I calculate the power at the point? So this is the power at that point. Same point, omega 1, omega 2, the power at that point. But in general, P max is this one. And what is the half power point? This condition must be what? Must be met. So you determine from that, are you getting a half? Then you solve the P. Let's solve the P. You get I naught squared over, if you are solving this P. So which means my P is equals to I naught squared. You write your I naught squared with the 2 multiply by R, but that 2 under the bracket, it's a root of 2. So which means you are dividing by 2, which means everything. So what is I naught R? This I naught squared R is the same as what? P max. Can you see it? Did you see it? Hello? Eh. We are here now. I naught squared R, which is the current initial squared multiplied by the R.
It's
You
for
can
P max.
replace that statement with this one, P max, because this is the same. Instead of writing that, I can write what? P max. So in other words, what I mean is just, instead of writing I naught squared, now I'm going to write P is equals to, instead of writing I naught squared R, I'm going to write P max. Then the 2 is there. So if I get that my condition has been met, otherwise the left-hand side is equals to the what? To the right-hand side, which I was trying to test. Therefore, I conclude that W1 and W2 are what? Half power points.
Oh.
That's what you want to conclude. W1 and W2 are half power points. Simple thing. This is a short derivation. So first, you must know the first definition of a maximum power point, which means P max. So the maximum power is this one. But what is the power at W1 and W2? So this P, which is we are referring to P, the power at W1 and W2, this power P, that is the one which is I naught over what? Root of 2, then you square and you multiply by R. When you simplify that P, you are getting this. So in other words, that P is equals to, where there is I naught squared R, you replace that I squared R with P1, P max. Then everything divided by 2, which is at the denominator. Then you have the same symbol there. Therefore, W1 and W2 are half power what? Points. Any question there?
Hey, I'll just have to do that again on my own.
So
Yeah.
first we are starting with the definition of the maximum power what? Point. And what is the power at W1 and what is the power at W2 is given by that formula. So first know the power at W1, know the power at W2. So first thing that you are going to write, what is the maximum power point? It's given by that. What is the power at W1 and W2? From the instruction which were given, I is equals to I naught over root of 2. So where there is I naught, you are putting I naught over what? Root of 2 squared. You simplify the P, you are finding that P is equals to this is the same as this. So you replace that with P max over the 2, which is this one, over 2. So if this condition has been met, to say P is equals to P max over 2, therefore we conclude that W1 and W2 are half power points. If on the question paper you were given that I is equals to I naught over root of 3, where W1 and W2 going to be half power points. They are not going to be half power points
Please
because when
repeat
you
that.
square this one, it's going to be I naught over 3 multiplied by what? By R. So it's not going to be over 2. So it's not a half power point. Do you get the logic there? Because for it to be half power, the denominator must be a root of 3, a root of 2, not a root of any other number. You change that root, you put a root of 5, a root of 6, it won't be a half power point. It can only be a half power point if that current root of 2, because we are going to square this one. Then when you square, it becomes I over 2. But we know that I naught squared multiplied by R is P max. So we conclude that W1 and W2 are half power points.
Points.
That's all, guys. There's nothing difficult there. There's nothing difficult.
So we're done with question 2.
2A. We are not done with the word question. Number
Oh.
A, this is 2A, which you are going to write. So this one is what you are going to write for half power points. So this is 2. That is the one for half power points. Right. Then the other one, which we are supposed to find for 2A, it's saying show that the half power points are done. And the change in omega in that W is W2 minus W1, which is the same as R over L. So we want to show that the change in W, what is the question second one saying? We want to show this one. Now we want to show that this is equals to W1, W2 minus W1. And this can be simplified to R over what? Over L. That is what we are just showing. So that is what we want to show. But what information are we given? Check the function that we are given for the EMF. Remember, in metric level, your EMF, isn't it? It was just voltage.
Mhm.
Then they say the EMF of the circuit is 12 volts. That is what we used at metric level. But now, your EMF you are being given as a sign, as a function, E naught sine omega t, which means it varies with time. So you must take note of the changes. But these ones, we are used to them for EMF at metric level. When you are doing circuits, they were there. It's only that now they are a bit advanced because it's now university work. Okay. So let's work this one out. So that's what we are trying to solve here. All right. So the peak current I naught at W is equals to omega naught, which was given in the problem. This information is given. This one is given. And then the current at W1 and W2, this is the current at W1 and W2, which we were using this one in the previous question when we were determining the half power points. I naught over root of 2, that was the current for W1 and W2. And then the EMF, E naught sine omega t. We are given this. Any question here where you say, I don't know where these things are coming from? Any question there? We are happy. Are you still there or you are not?
We are still here.
You are still here. I'm saying the information is given. Where is it given? I have highlighted. This is your EMF. This is the EMF, E naught sine omega t. Then they are saying I naught equals to the peak current is equals to the current here. And we are told that I is equals to I naught over root of 2 here. So I'm saying this information is coming from the given information from the question. This information that we are having here. Yeah. EMF, the current at W1 and W2, and also the peak current I naught at W equals to W naught. This is coming from the question. Then those are the formulas which I said you must know. But when you are calculating what is it that you want to solve? We want to solve for the change in W. So first you must find what is W1 and what is W2. Once you find W1 and W2, then you are able to find the change in what? In W. Then you simplify, you see if it's equals to R over L. So the angular frequencies, which is our omega 1, omega 2, where current is I naught over root of 2 from the given information on the question. Show that the power, this one we have done it. Now we want to solve for number 3, which is W1 minus W2 is equals to R over L. W2 minus W1 is equals to R over L. Right, so which is the third step, which means you need W1 and W2. All right. So W1 is coming from here, where we are supposed to solve the frequencies W1, W2. So solve for the frequencies, angular frequencies W1, W2, using this formula. So we start here. Current is given in the circuit by I is equals to E naught over the impedance Z, Where is the Z coming from? Where is the impedance Z coming from? Here. The impedance in the series LCR, inductor, capacitor, resistor, circuit, our Z. So the formula which they used here, the first one, is current is equals to E naught, the EMF over Z. From metric, what did we say? Voltage is equals to resistance over what? From your metric, physics, voltage is equals to resistance times what?
Current.
Times current, isn't it?
Mm.
Which is the same with here. We are given EMF, which is the voltage. This E naught, it's EMF. So if you want I from your metric mathematics, I is equals to, which means it's the voltage over the what? The resistance, isn't it? So which is the same here? Current, which I'm looking for, is equals to the voltage, which means it's the EMF, the supply of the battery, which is E naught, EMF, over the resistance. But now, because your circuit does not only have resistors, it has inductors, it has capacitors. So all those components, they are being represented by what? By Z. Only in metric, your circuit was only having a component which is called the resistor only. But now we have many components, resistor, inductor, capacitor. So I must put a what? That symbol Z. Any question there?
I don't have one.
Because the Z is representing the resistance, this one, which is the R, which I replaced here, because of many components. So at resonance, which means now they are just replacing the resistance with the Z. The resistance with the Z, which means other components at resonance, there will be not. Then you'll be left with this one only. So which means your Z, in other words, it's equals to the R at resonance. That Z will be equals to R. Why R? This is out, this is out at resonance. The inductor and the capacitor is not. Therefore, Z is equals to the square root of R squared, only at resonance, which means Z is the same way as writing what? Square root of R squared is just what? R. Why? We have cancelled the inductor, it's 0 at resonance, and the capacitor is also 0 at resonance. So which means the Z becomes what? R. Any question there? How we found this Z? The formula I showed you where it is coming from. Voltage is equals to resistance times current. But now your voltage you are given in form of EMF, and your resistance is now having, your circuit is having many components. It's not only a resistor, it's also an inductor, capacitor, and resistor circuit. That's why you are using Z for impedance. But at resonance, everything becomes 0. These ones, they are becoming 0. That's why Z is only going to become square root of R squared, which is Z is equals to R. That's where we are here. Any questions so far? For those 2 steps, we have not gone far. Only 2 steps. By starting by I is equals to E naught, which is EMF, over Z, which is the impedance. That is what you must know from the definition. Then you say at resonance, Z, which is the impedance, is just equivalent to R, which is the resistor. Any question? That's why where there is Z on the original formula, Now you replace the Z with an R. Instead of writing this formula, now I replace where the Z, I'm putting what? R. So it's a matter of playing around with formulas. Then you come, you tell us what we are given from the question. I is equals to I naught over what? Root of 2. I is I naught over root of 2. Are we together there? Hey, I'm talking
Oh,
alone.
yeah, a lot. Hey.
I'm talking alone today.
No, you're introducing new stuff. So,
Isn't it? It's question number 2.
but the I think the formulas, ne? We have
Yes.
electricity.
For impedance, yes, I understand.
Mm.
Yes, I understand. So, but let's push this one so that we finish this one for B, so that you write something bit by bit. Okay. So I is equals to I naught over root of 2, and Z is equals to root of 2R. Z is equals to root of 2R. Are we together? And where is it coming from? When I is equals to I naught over root of 2, this was given from the question. It's given this one. Where there's I, put I naught over root of 2. Then what is Z going to be? Z will be root of 2 over R. I want you to tell me, where is this coming from? Because previously you told us Z is equals to R, isn't it? Z is equals to R. When it was at resonance, we cancelled everything and we found that Z is equals to R. Now, where is the idea of saying Z is equals to root of 2R coming from now? Where are we getting that idea from? What is I naught equals to?
Isn't it I multiply by square root of 2?
That's correct. So, which means from this information that we are given there, when you say I is equals to I naught. So which means I naught there, it will be root of 2I. Root of 2 multiplied by what? By I. Can you see? And when we were defining our current, where we were saying current, this I is voltage over resistance. So which means the current which I'm talking about, it's root of 2I. So in other words, you are saying root of 2 multiplied by I is equals to this E naught over R, which is your voltage. So it will be E naught over the R. But that R, we said it's a Z, which means at resonance here, we are going to put where there's R, now we put a Z. So that we now equate Z to R. So we want a relationship between Z and R at the resonance. So the magnitude of root of 2, that's what I'm applying both sides. I don't know if it's clear. If you have understood it, you say it. If you want me to re-explain, we explain again. Because once you fail to understand here, because all here now we are just replacing values, putting it back in the formula, we substitute. Down there is now easy. Then we find W1, W2. The only challenging part is just here to understand the change of variables, where the Z, how the Z changed now to 2 root R. So that once you are done, where it's saying impedance, this formula Z, where there's Z, now you replace with 2R. That's what you're just doing. Where there's this Z, you replace with 2R. Here, this impedance. Z, where there's Z here, you replace with 2R. That is the 2R which you are going to replace with. Root of 2R, sorry. Root of 2R, not 2R. It's root of 2R. Then everything that is inside stays the same. We are having R squared, then you write R squared. And then we are having XL. Now, XL can be written as omega what? W. XC can be written as 1 over omega C. C for the capacitor, L for the inductor. L for the inductor, C for the capacitor. So that's what we are doing there. So we are just converting the variables. The other one, it's omega L, and then the other one, then you square. Then you square. So we are squaring everything inside the bracket. After you square, you find the value of R. And remember, everything is under the square root sign. How did we remove the square root sign? Yeah. How did we remove the square root sign here? How did we remove this square root sign? Which means you square both sides. When you square here, squared. When you also square this side, squared. Then you'll be left with 2R squared. And then this is what is under the bracket. Group like terms together, which means R squared comes to the left. Then this will be 2R squared minus R squared, which is R squared. You have moved it. Then on your right hand side, you are just having omega L minus 1 over omega C squared, which is on your right hand side. Then now you solve for R. What is the value for R? Which is the square root of the right side. The square root of the right side. So it will be R is equals to the square root of omega L minus 1 over omega C. And then everything was under the square root. So which means you remove the square. Then you'll be left with just what is inside the bracket. That minus 1 over omega C without the square, which is this one. And where is the value of absolute coming? Which means R must be a number that is positive. Remember, absolute, you can't have a resistor that is what? Negative. So this symbol for absolute is indicating to you that R must be positive. So the absolute, those lines, these lines, they are indicating that R is positive. So once we are done here, we want to solve for that R. So which means the absolute of this number. When is it positive? Plus or minus r, which means omega L minus 1 over omega C is equals to plus or minus r, which means it's the absolute. That's what it, in other words, what it means. When you are defining this in terms of absolute, which means that number must be always positive. So at resonance, this one we already calculated it for z is equals to root of 2r. It was given. So we did the same, squaring both sides here to remove the square root, which means you also square here, squared, you also square this side, you square, then the root is out. You come back. So now when you solve for r, what is the value for r? Hello, are you there?
Yeah, I'm still here.
So up to here, we are together here. Then you solve for the value of r. That is the value of r. All right. Then using the quadratic formula, here, this step, where you are solving the quadratic formula, it's like omega is now your x. Omega, it's like your x squared, where it says plus or minus r omega, which means it will be plus a constant with an x, and then the last one is just a constant. So you can use quadratic formula to solve. We are using quadratic formula to solve for that omega. So in other words, we are solving using the quadratic formula, whereby which one is our a? The number which is in front, which means we are solving for omega. So you look at the coefficients. L is your a in this equation. The L here, this is your a. And then the R is your what? It's your b. That R, it's your b. Then the whole constant, the whole number here, 1 over c. That is your constant, which is your c. So when they say minus b, which means it's plus or minus r, this is your b. It's minus b, plus or minus. Then obviously, this for the equations, it means 2 roots, plus or minus square root of b squared. So it means b squared minus 4ac. So which means my a was L. So b squared, we said b is r. So it's b squared, which means it's r squared, minus 4 times a. Our a is L, which means times L, times c. C is bracket negative 1 over c. That's how we came to say it's r squared. Negative and negative, it's a plus. This is the plus, which is 4L over c. That's how we got that 4L over c. Everything for a quadratic equation, you divide everything by 2a, which is 2a is your L, 2L. That's what happened there. So now you want to find the solution for the first one. What is the omega? 1, 2. So the first one will have a positive here. You remove the one with the negative. Remember, it's plus or minus. So the first solution is the number that is going to have a positive only. Then the other solution, it will have a negative. Instead of a positive, the other solution is going to be having a negative, which means minus. So if W1, it's here, it's positive, negative, the other one will be positive. That's why we are going. All right, let's solve it. So we are here where we want to, since the omega must be positive, our omega must be positive, which means the absolute. That's why we're putting that absolute must be positive. We are not going to get a negative number. So which means here the R is supposed to be positive. So here the R is positive, and also here the R is also going to be positive because of the idea that omega must be positive. So we disregard the negative here. This negative plus or minus, which is there. You only remove the negative because omega must be positive. Then you remove that omega, that negative. Then we are left with those two solutions. So here, you know, it's obvious it must be a positive. So if they are saying, what are the two roots? The two roots for omega 1, that is the root number 2. With the other one is having positive here, other one is having negative. I mean positive, that one is negative, which is different from quadratic, whereby the first term is different. Here, that's where it's different. But in this case, the omega must be positive. That is the restriction. Unlike for quadratic, we can have a negative root and a positive root. But in finding the roots, we used a quadratic formula. So once you are done, we solved our roots, then you put those roots in the equation. Now we want to solve for change in what? In omega, which is this delta omega, which means we are subtracting change in omega. We are subtracting omega 2 minus omega what? 1. So let's subtract now. We are given our values for now, omega 2 and omega 1. So we are going to subtract 2 from 1 to get change in what? In omega. That's what we are just doing now. So let's subtract. Let's subtract. We see what we are getting. So omega 2, so here we are just saying change in omega, like that, is equals to omega 2 minus omega 1. Then you find the roots. So what is your omega 2? This is the one, that's the values that we got. Omega 2 is positive. Omega 1, that is the one that was negative with R. So when you subtract these two, let's subtract the 2 with the negative, that's where you are going to get a positive. So negative, here there is a positive, P, positive R. So you solve it. How are you going to solve it? So negative, positive. So it's going to be R over 2L, the first one, plus root of R squared, which is the bracket, plus 4L, which is 4L over C, everything here over 2L. Then you continue to the right. Then negative, it's a plus. So which means you continue. Plus R over 2L is R over 2L. Then this negative times this positive is going to be negative. So it will be minus what? Root of R squared. Minus root of R squared plus, again, 4L over C, everything over 2L. They are sharing the same denominator. So from here, you are going to see that if you are to solve this, which means these two, they will cancel out because of the negative and the positive. That's why they are phasing out, because of the negative and the positive. Therefore, you'll be left with the change in omega is equals to R over 2L plus R over 2L, which is 2R over 2L, which means the 2's they cancel. Then you come back to the formula which says change in omega is equals to R over L. Any question there? Any question? It's only a mathematics. What we are just doing here, seeing the mathematics, numbers which are cancelling, positive, negative, you must be in a position to identify. Just like the way we are doing it. Things which are cancelling, you cancel them out, like the way I've indicated. What is cancelling? It vanishes. For example, we are saying because of we are adding the same thing and you subtract the same thing. So these two, they go. So that was the trick to identify that. Then you'll be left with a change in omega is equals to, which is equals to, that change in omega will be equals to 2R over L, R over L plus R over 2L. You add, which means you are going to get 2R over 2L. So the answer is R over what? Over L. So for now, you can write A and B. So this part, which we proved to you, is the B part, number 2, but number 2B, we are proving this. Substituting, so this is part of 2B, which we are indicating. This is number 2B. The 2B, yes or no? Let's check. It's still part of A. 2B, we have not touched 2B. So in our next session, we are going to touch 2B, which is a long derivation again of showing that the quality factor of a circuit is Q is equals to W naught L over R. So we'll be showing this one again. So in the meantime, let's write those two parts for showing half power points and for showing that these two are what? Are equals to R over L. I have shown it now. So we have a lot to write down, and we continue tomorrow with this last part for B, and we start with question number 3.
Okay.
Any comment, any take before we conclude? We are quiet.
Oh.
The physics is now tough. Yeah.
I'll need to
Oh,
do
they are now
this.
sleeping now. Yeah.
Not yet asleep.
All right. So I will share the PDF and also the recording. You also requested for the previous one, isn't it? So I will send 2 of those links to the group. So I have given the answer for A. What is left is for me to explain this one. So it will be in our next session so that we are done with question number. So our next session will conclude question number 2B, and then we do question number what? Number 3.
Okay.
Isn't it?
Yes.
So question number A, 2A, it has 2 parts. 2A was having 2 parts. Show that W1 and W2 are half power points.
Yes.
The power at W1 and W2 is half power point. And also show that the change in W, which is W2 minus W1, is equals to R over what? Over L. This is what we have shown now. When we're showing this is equals to R over L. When the middle term was vanishing here, because we are adding and subtracting the same thing, then the 2's they cancel. Then it shows that it's R over L. That is the part A. Then part B, we'll continue this one for part B, and we'll start with question number what?
3.
Yes.
Okay.
Okay.
Thank you.
Well, let's call it a day for today. I've added another extra 20 minutes because these are long derivations. So it's fine. We'll continue tomorrow. Let's have a break here. You digest everything. And then where you need clarity, you still ask tomorrow. We still have another day.
All right.
Thank you.
Thanks.
Okay.